Okay, we want to continue with the problem formulation and we'll solve another example. This one is a little bit more straightforward. It says that consider the problem of minimizing the purchase of fuel oil when it is needed to produce an output of 50 megawatts from a two-boiler turbine generator combination that can use fuel oil or blast furnace gas or any combination of these. The maximum available blast furnace gas is specified. What they're saying is that there's a certain unit you have, it's a two boiler turbine generator combination, and it can work with two different kinds of um, um, fuel in quotes. So it can work with fuel oil, or it can work with blast furnace gas, or it can work with a combination of them. But the maximum amount of blast furnace gas that we have available is specified. So as we read, we'll see that mentioned. Then it says that by applying nonlinear curve fitting, we obtain the fuel requirements for the two generators explicitly in terms of megawatts produced. So for generator 1, we have the fuel requirements for fuel oil in tons per hour, and we have the expression there. Then for the blast furnace gas in fuel units per hour, we also have the expression there. So what they're just trying to say is that if I look at generator 1, right, and I'm considering fuel oil, this is what my expression is going to be for fuel oil. If I'm considering blast furnace gas for the first generator, then this is what it's going to be. Then we are saying here that x11 plus x12, so those are the variables in these expressions. They are going to be the output in megawatts of generator 1. And the range of operation of the generator is 18 less than that output value, less than 30. So they're just saying that if I add x11 and x12, it gives me the output in megawatts from the generator. But for generator 1, it should be in between these two values. Then we do the same thing for generator 2. So we get a G1. So this is for fuel oil. They say that the requirement for fuel oil is G1. So this is for fuel oil for generator 2. And then G2 is blast furnace gas for generator 2. We also have the output, and then we have the ranges going to work in. And it says that it is assumed that only 10 fuel units of BFG are available. So remember, when we said that, they said that the maximum available BFG is specified. So they've now specified it here that only 10 fuel units of BFG are available each hour, and that each generator may use a combination of fuel oil or the blast furnace gas. It is further assumed that when the combination of fuel oil and blast furnace gas is used, the effects are additive. So what they are just trying to say is that if I should add fuel oil and blast furnace gas, I can just take the expressions they have and then just add them. The effects are additive, so I can just add them up. So formulate an optimization problem that produces 50 megawatts from the two generators in such a way that the amount of fuel oil consumed is minimum. So we'll look at the question bit by bit so that we can understand the whole thing behind it. So from the question, what are we trying to minimize? Is the amount of fuel oil. We are trying to do this in a way that we will still produce 50 megawatts of power, right? But with the question, we are told that we want to produce the 50 megawatts from two generators. And the two generators, they can work with a combination of fuel oil and blast furnace gas. So we can work with either fuel oil, blast furnace gas, or a combination of the two. But the maximum amount of blast furnace gas that we can use, it has been stated for us in the question. That was 10, right? So it was stated as 10 fuel units at the end of the question. And we have some equations we can use that also already stated. So some of the constraints have already been listed out for us in the question. So one of the things to note is that from the equations that we see, anything associated with generator 1 has a subscript to be 1. Anything associated with generator 2 has the first subscript to be 2. Right, so let's go back to the question so that we can see what I'm trying to say. So this is for generator 1. So so if you look at x11, x12, x21, x22, so I'm saying this based on the x values. Anything associated with generator 1, the first subscript is 1. So if we look at it, for generator 1, the first subscript is 1. First subscript is 1. But the moment I move to generator 2, the first subscript is 2. First subscript is 2. Then when I'm working with fuel oil, the second subscript is 1. So if you look at it, the second subscript here is 1. Second subscript here is 2 for blast furnace gas. if I should come down over here, this is for fuel oil. Second subscript is 1. Here, second subscript for blast furnace gas is 2. So that's the notation that they were using in the question. So the very first subscript you see will tell you which generator it is working with. Then the second subscript tells you whether it is fuel oil or blast furnace gas. So we know that it's the amount of fuel oil that we want to minimize. But how do we write this objective function? So we can just say minimize, then we can give the function a label. So z is equal to f1 plus g1. So f1 is the fuel oil in generator 1, g1 is the fuel oil in generator 2. So once again, back to the question so that we can see that the question told us the amount of fuel oil in generator 1. That was this expression over here. Except for generator 1, we have the fuel oil requirements for fuel oil. So we have the fuel requirement for fuel oil in terms of in tons per hour. So this is the fuel oil in generator 1. Then for generator 2, the requirement for fuel oil is given by G1. So what we are trying to minimize is the amount of fuel oil in both generators. So it will be F1 plus G1. Then, so we have the expressions for F1 and for G1 as well. Now, what constraints do we have? We're told that the maximum amount of the blast furnace gas is supposed to be 10 fuel units per hour. So F2, just like we found F1 and G1 to be for fuel oil in 1 and 2, F2 and G2 are for the blast furnace gas in 1 and 2. So F2 is the amount of BFG required in generator 1, GT is the amount of BFG required in generator 2. So F2 plus FG, this should be less than or equal to 10. The maximum available is 10. If that's what is available, the maximum available, it means nothing. You can't cross that value. So it should be from 0 to 10. Okay, so we have our F2 and G2 expressions there. And the question gave us some other constraints, right? So the question told us that x11 plus x12 will be the power output from generator 1, and I left the sign, and 18 less than or equal to x11 plus x12 less than or equal to 30. So it just means that x11 and x plus x12, when you add them together, the value should be between 80 and 30. Then for generator 2, they gave us the expression for the power output as well, and they said the value should be in between 14 and 25. So the last thing is, at the end of the day, we are supposed to produce 50 megawatts of power. So if we add the power output from generator 1 and from generator 2, it will sum up to 50. So if I take this is the power output for generator 1, the power output for generator 2, it should sum up to 50. So that becomes my last constraint. So we can list out all our equations, right? So we're minimizing the function f1 plus g1, and we know the f1 expression, the g1 expression. So we just put all of them together and add. And if we simplify, we'll get this expression we see over here. So if we just take what we had for f1 and f2 and simplify, this is what we should get. Then it is subject to, so now the constraints, f2 plus g2 should be less than or equal to 10. We have this long expression over here, and then we can simplify it as well. So the 1.5742 adds to the 0.7266 and gives us 2.3008, and almost everything else is the same. Then the other constraints, we had 18. Why is it that it wasn't up? Okay, I think it didn't appear well. So we have, it's supposed to be 18 less than or equal to x11 plus x12 less than or equal to 30. 14 less than or equal to x21 plus x22 less than or equal to 25. Then the sum of all of them equal to 50. So these become all our equations. We have our objective function, we have our constraints as well. So this is how you go about these questions. Always look for the objective function, look for what it is dependent on. Go back to the question and now look for your constraints and how they can be related to those dependent values, right? How they can be related to those decision variables that you found. Okay, so this will be it for this question. We'll continue with the other questions later on.